Hi, how are you?
Good.
Are you listening me well?
Yes.
Yes, is my voice with good quality?
Yeah, it's good.
Yes.
Okay. So, uh, so let's to wait a few minutes more to see what happened here. 35 people. Yeah. How was this week? It's fine this week? Everything was fine this week? No coronavirus near. There is case of coronavirus in in your neighbor, in your home, in your family. There are cases or not? Nothing. They say lately they say that coronavirus is a lot. No. Oh, okay. Okay. Good. And are you seeing my video now?
No.
What I can do is not working. Can you give me an idea how can I fix? Let me see how can I fix this. How can I see to make my video is not working?
Sir, is your webcam plugged in?
My webcam is on the computer. Is I'm using a Mac. It was working, but I don't see that it's working now. Let me see. They say camera, FaceTime. Okay. Let me see. Video. Now, can you see me? No?
No.
Well, I don't know how to fix this thing. Let me see. Let me see if I can fix it. Now, can you see me now? No?
No, it's still black.
I go to the video configuration.
Right. Can you, when you test your webcam, the video configuration, can you see yourself?
No?
Sounds like a problem with your webcam or the webcam option that's chosen. There might be a few options there. You might have to choose a different one.
Do I go to setting on the computer to see the web camera?
If you search in Windows Start for webcam, it should show some kind of option.
I have Apple. I have Apple.
Sorry, Apple. It should, if you type in webcam, it should show something.
Let me see. Webcam. see. Wow, no. Webcam, let me see. Well, I will tell my son to repair it. Just a moment. Salvi. Just a moment. Okay. Let me connect my iPad. I hope that Mira, ven y arréglame la cámara que no funciona. Arréglame la cámara que no funciona. Sí, sí, arréglame la cámara que no funciona. ¿La cámara? Sí, de aquí, ven, ven. Sorry. Okay. Okay, sorry that you don't see me today. I will try to fix it. My son is trying to help me to fix it. So we share my screen. Or let me see. Mira, es que no se ve la pantalla negra. Esta pantalla está.
Pon acá. ¿Qué quieres hacer?
Pues que me vean.
Pon acá.
Ajá.
Video.
Aquí.
Comparar video.
Ajá.
Y pues cuando no. Aprieta.
Ajá. No sale nada.
Pero te están esperando.
Yes, pero no importa. Puedo empezar ya. Empiezo sin el video. Okay, I'm sorry, we will make the class without the video. Very sorry that you cannot see me. I don't like. But I don't have any other thing to do. So, let's go to start. ¿Dónde está mi bolígrafo? Aquí. Puedes cerrar esa puerta. Let me tell you something. I have uploaded some problems for Newton's law. I will upload also some problems for work and energy, and I will upload all the videos for work and energy that will allow you, I hope, to understand better what's going on with work and energy. And you will have to do some homework for work and energy, okay? Let me, okay. So how many people we are now? We are, let me see. Let me close here. So let's go to do one easy problem. One easy problem could be like this. Imagine you have an object of mass m. The object originally is at the height y0. And you want to know if you leave it from this position with velocity, initial velocity 0, You want to know the mass m, what will be the velocity when he has moved this displacement, delta y. So initially the velocity is 0, and in the final state, the velocity is big because there is acceleration here, there is g going down, that is accelerating the body of mass m. So the body is increasing the velocity, and if you make horizontal planes like this, you see the horizontal planes. For every, he starts on this horizontal plane, and when he moved to another horizontal plane, and when he moved, the velocity that it has in every horizontal plane is different. It's increasing the velocity. On this plane, the velocity is 0. On this plane, the velocity is like this. And on this plane that we want to calculate, the velocity is bigger. And this plane, the h is, let's say, h. So how we will calculate from A to B the velocity? So we'll say two things. First things, we will calculate the work done from A to B, and we will make this work to be the chain of the kinetic energy. From this equation, we can find the velocity at B. This is what we want to find. The velocity at B is, we know the velocity at A. So we'll do it. What is the work done from going to A to B? Well, what is the force that is acting from going to A to B? The force that is acting is the weight, mg. And the force is going down. And the displacement delta y is from A to B. So it's from the point A to the point B. This is the displacement, delta S. Delta S. So will be mg by the displacement. The displacement is y initial minus y final. And I want to find the velocity at this position when he is in the height y. This is y, let's say y equal 10 meters, and let's say y0 equal 50 meters. So you leave a mass m from the point A that is at 50 meters, and you wonder when he has displaced 40 meters, that is at 10 meters from the ground. What will be the velocity? So the only force that is making work is the mg. Y and delta G will go in the same direction, because mg and delta Y, you see that mg is going down, and delta Y is also going down from point 1 A to point B. So delta Y is also going down. So the work is positive. This work should be positive. And the work is mg by y0, 50 meters, minus y final. Y final, I said that is how much I said? 10 meters. 10 meters. Equal what? This is the work done from A to B. Equal mg by 40 by the displacement. Equal what? Can you tell me? Equal what? The work done by the force is equal what? Can anyone tell me? It's here. It's on the blackboard. Is equal what? Equal.
The change in kinetic energy.
Correct. So we make this equal 1/2 m VV squared minus 1/2 m VA squared. But we said that initially the velocity at A, we leave it with 0 velocity. So this term will be 0. So as a result, m with m will be cancelled. G by h, the height between the two planes is h. H is the height between the two planes, the 40 meters. G by h will be 2 times b by h, will be bb squared. So the velocity at b will be a square root of 2gh. Is that problem clear? Is this problem clear? Should I tell you again?
I just don't know where you got the original equation from, Professor. Like the original equation to work out the problem.
This one?
It's the work on A done to B.
The work by the force. In this case, the force is the weight. In going from A to B equal to the variation of the kinetic energy.
Okay.
You don't know, Diego, from where I...
No, I do, and then that's equal to the negative change in potential energy too, right?
Is also equal to the negative. So we will do now the problems using the other part. Okay?
Okay.
So what I want to know is what I did completely clear, or should I repeat what I did?
I understand it.
It's clear.
Should I repeat it or not? So what I did is the following thing. I have 2 points, A and B. I will calculate the work from going to A and B, to get from A to B. Well, I will calculate the work done from A to B. The work by what force? Well, the only force that is here is mg. So I will calculate the work done by this force. I will calculate F scalar ddy, delta y. F scalar delta y will be Fy delta y. The work will be minus, sorry, just a moment. Minus mg, this is the force Fy, by delta y. Delta y is, is delta y, yes. Minus mg j scalar delta y. Delta y is the vector that goes from A to B. It's the vectors that have this length, the length is 40, we said, and it's going down. So it's the vector 40j minus, because it's the vectors that go from A to B. This is the vector delta y. So I did the scalar product between 2 vectors. The first vector is minus mgj. The second vector is minus 40j. This will be plus mg by 40. And I said, this is the work in going from A to B. By who? By the weight, by the force. And this work I have proved 2 times. 2 times I have proved that the work done by the force mg by 40 accelerate the body, makes a change in the velocity. And the production of kinetic energy is related to the work. And how is related? Is 1/2 mv squared minus 1/2 mva squared. Okay, so I said, okay, the m's will go on the equation. The m will not take place on this equation. It will happen the same thing to any mass m. It doesn't depend if what you throw is a car or if a small thing with a small mass. It does not depend on the mass, the velocity. So g by 40 will be 1/2 of bb squared. Oh, and this term is 0. Why is 0? Because I said that I launched the body with initial velocity 0. I could have said that the initial velocity is plus 30 meters per second going up. Or I could say that the initial velocity is minus 30 meters per second going down. But g squared will be 900 here. So I calculate in the case that v is not 0, I have to put minus 1/2 of 30 squared. In case that I have. But in my problem, I said that this velocity, the velocity at the point A, is 0, so this term will not be here. So 2 by 9.8 by 40 will be the velocity v squared. So the velocity at the point B will be a square root of 2 by 9.8 by 40. And in this way, we calculate the velocity at any point. Okay? So let's go to do another problem. Let's say that I have the point A here. And let's say that I have the point B here. And let's say that I throw it with a velocity v equal 30 meters per second. And now I want to find the velocity of the object when he will be at the point B. So this is a plane, an horizontal plane. This is an horizontal plane. The object will be subject to the weight. The object will be arrived to some maximum height and will go down and will pass through the point A with certain velocity, with certain magnitude of the velocity. And I want to find what is the velocity at this point if the difference in height is 40 meters. What I will do, exactly the same thing. I will find what is the work. I already find what is the work from going to A to B. The work in going from A to B is mg by h. So this will be equal to the variation of the kinetic energy. Is bv squared minus 1/2 mva squared. But now the a is not 0, but the m's will go out because they are common thing on the equation. I can take it out on the m. So g by h, 2g by h, will be bb squared minus va squared. So vv squared will be equal va squared plus 2gh. So vv will be a square root of va squared, 30 squared, plus 2 by 9.8 by the height, 40. And now the velocity in this case, when the particle passes through the point A, will be bigger or lower? Huh? This velocity will be bigger or lower than in the first case? Well, in the first case, the velocity was this. In the second case, the velocity have the same term, 2 by 9a by 40, but it has 900 here. The velocity will be much more bigger when it passes through the point B. Is that clear? Yes or no?
Yeah, that makes sense.
Okay, can I continue?
Yeah.
Okay. Now, we are going to do the problem in a different way. What is the different way? One, we find the potential energy that is associated with the force F equal minus mgh. And from the force F equal minus mgh, there is a potential energy that depends on the A that is simple mgy. So
Wait, Professor, why is it negative mgh?
this force?
Yeah, why is it negative mgh?
Oh, no, sorry, not the H. mgg, sorry. The force is the weight, mg. Sorry, the force is the weight, is minus mgj, and for this force exists a potential energy that do the job. That when I calculate the work from going to A to B, if I use the potential energy as E sub P of A minus E sub P of B, will be the same thing that calculated the work. So let's go to do the problem in this way. In this way, we don't calculate the work from going to A to B. We know that the work is the final cinetic energy minus the initial cinetic energy, because the work is the variation of the cinetic energy from going to A to B. And in this way, we know also that the work in going from A to B is the potential energy at AY minus the potential energy at the final position. Initial position is the A, final position is the V. So I want to find B, I want to solve the two problems that we have solved using this equation instead of calculating the work. In the first part, we calculate the work and we put it equal to this, equal to the variation of the cinetic energy. In this part, in this second part, we don't calculate the work. We assume that exists a potential energy that do the job in the way that you don't have to calculate the work. That E sub P initial minus E sub P final will be the work, so you don't have to calculate it. So let's go to make calculation to see if this is the same thing. On the first case A, VA was 0. The YA was the initial point, was 50 meters. YB was 10 meters. So my equation will say, I start here. I start putting numbers here. 1/2 m BB squared. Remember that what I want to find is BB minus 1/2 MBA. BA is 0, BA squared is 0, equal to mg YA 50 minus mg YB 10. Okay, so I take the m out.
Wait, you lost me there, Professor. Why is on the right side of the equation mgya minus mgyb? What is why do we need that in this equation?
Okay, so for this force, for the force minus mgj, we say that it exists a potential energy, and the potential energy is mgy. So
That's the formula for the potential energy, mgy.
Yes, because we can calculate it. I show you how to calculate it. If you want, I can show you again how to calculate this potential energy. And also on the modules that I'm creating, I'm showing you how to calculate this potential energy.
Okay, that's fine.
On last day, if you remember, I give you the force F equal minus kx I.
Yeah.
show you that the potential energy associated to this equation, to this force, was 1/2 kx squared. Well, it happened the same thing. The force is mg in the j direction, and the potential energy is mgy. If you want, I finish the problem and we calculate again this potential energy because it's worth it to review that we know what we are doing, okay?
Sounds good, Professor.
Okay, so mg is 50, sorry, here is 50, okay? So I will have, the m will go and I will have bv squared equal 2 times g50 minus g10 equal 2 times 50 times g minus 10 times g is 40 times g. Oh, I will have the same result, a square root of, and the 2 is here, no? The 2 is here also, on the first part, right? 2 times, was my result. Oh, sorry, this was my result. The first result, VV equals square root of 2 times 9.8 by 40. This was my first result. Oh, I found the same result using the potential energy. A square root of 2 times 40 by j. This is a square root, of course, of 80 by 9.8. That is, I don't know, whatever it is, okay? If we do the second part of the problem, meaning that in the second part, we use a velocity initial VA equal, I can remember, 30 meters per second, and we use the same method to solve this problem, we will do the same thing. What it will mean to do the same thing? B. So now V sub A is not 0, it's 30 meters per second. The 30 meters per second, the velocity, the vector can go up or down, but I take in account the magnitude of the velocity. The magnitude is 30, and I don't mind because at the end, the equation will involve VA squared. So even if I put the minus 30, it will not happen anything because it will be translated to a positive number. So the part B was saying, if V sub A is 30 meters per second, what is V sub B? If the difference in height, Y1 was 50 meters and Y2 was 10 meters. Well, I will do exactly the same. I will say the work is equal to the variation of the kinetic energy, but also the work is equal to the minus variation of the potential energy. And I will not calculate the work. The work, I will calculate it here. And I will put it here equal to the variation of the kinetic energy. So, what is the work? The work, what is the variation of the kinetic energy? Is 1/2 m BV squared. BV squared is what I want to find. I want to find the velocity when the object arrives to the point B, minus 1/2 m VA squared. Oh, but VA squared is now 30. Okay, I will put it equal to the variation of the potential energy. The variation of the potential energy is E sub P final minus E sub P initial. This is the variation, but because there is a minus sign, this is E sub P initial minus E sub P final. But I said that E sub P is mg by y initial minus mg E sub P of final, y final.
Professor, and what does y stand for in this equation? Is it are these
Well, the object
just the position of them on the
as the height, the object was here at the point A, was at 50 meters.
Okay.
E is at 10 meters. point B, 10 meters. So YA is 50 meters, YB is 10 meters.
And Professor, how do we know which is initial and which is final? What do we know? What?
A to B. If you go,
Oh, okay, okay, yeah, yeah.
this is the initial, and this is good question. It's good question. And this is the final. A to B means initial and final.
Yeah, I just forgot that the problem was asking like the velocity from A to when we're going from A to B.
We can do it in the opposite way. We can do it from going to the point B, we convert it in the initial point, and the point A, we will convert it in the final point. We will later. Let me finish this. So we'll do like this. So 1/2, the M will go out. It's all over in the equation, and I will have 1/2 VV squared minus 1/2 VA squared. But in this case, I said that you will throw the ball from the point A with 30 meters per second. So will be 30 squared equal the variation minus the variation of the potential energy, G by Yi. What is Yi? 50. This is the initial position was plus 50 minus G Y final plus 10.
And Professor, the reason you're doing potential energy initial minus final is because of the negative sign that was in front of the,
Yeah,
and then you just flip them. Okay.
right,
Okay.
right. Because if I say that the work is minus the variation of the potential energy, what I'm saying is minus this. E sub p final minus E sub p initial, because the variation is always final minus initial. But minus the variation is initial minus final.
Okay. Okay.
Is that clear?
Yeah, yeah. That makes more sense. Thank you.
So in this case, we found exactly the same result that before. So VV squared will be, VV squared will be 30, let me see, it will be 30 squared plus 2 times G by 50 minus G by 10. But G by 50 is,
Wait, Professor, wouldn't it be 4 on the other, like 4 times G times 50 and G times 10, because you have 2 1/2s on the left side of the equation?
well, I multiply by 2 the whole equation.
Oh, okay. Yeah, you're right.
So those 2 will go, and these 2 will be 2 and 2. Okay?
Yeah, I'm sorry. That was my bad.
Don't worry. G by 40. 50 times G minus 10 times G is 40 times G. Do you agree?
Yeah.
So VV squared will be 900 plus 2 times 9.8 by 40. And I will obtain exactly the same result that I have obtained using the work. Using the work, I have obtained the same result. So, conclusion. What I am using is a tool called conservation of mechanical energy that say the following thing. E sub P initial minus E sub P final. And the word is E sub K final minus E sub K initial. Well, I will reorder the whole term and I will put all the initial terms in one side of the equation and all the final terms in another side of the equation. If I join this term with this term that are initial, and I join this term with this term that are final, I will get E sub K final, I will put it like this, plus E sub P final equal E sub P initial plus E sub K initial. And this is what I have been using all the time. This equation is what I was using all the time. So if I want to find this is called conservation of mechanical energy. And this is what I was using. Without you noticing, this is the equation that I was using. To prove you that this is the equation, I have the point, we solve again the problem. I have the point A, I have the point B. Let's say the case V sub A equals 0. Let's say the point Y sub A equals 50 meters. Let's say that I want to find V sub B. And let's say that Y sub B is 10 meters, so this is 10 meters and this is 50 meters. And the weight is, the force is going down, minus mgj. So I will apply this equation for simplicity. This equation says that the kinetic energy measured and the potential energy measured at the point A is the kinetic energy plus the potential energy at the point B. Oh, let's go to apply our equation to see if we can get the same result. The kinetic energy at the point A is 0 because I throw it with velocity 0. The potential energy at point A is mg by 50, Ya. mg by y is the potential energy, equal. The kinetic energy at the point B, this is what I want to find. This is what I want to find. And the potential energy at the point B is YB, is mg by y, is the potential energy. If it's the point B, will be mg by YB. Okay, if it's the potential energy at A, it will be mg by Ya, but Ya is 50, YB is 10, so I put it my numbers. mg by 50 equal 1/2 mBV squared plus mg YB 10. Okay, so I will obtain the same result. M will go out and we'll have G 50G minus 10G will be 40G equal 1/2 VV squared. Okay? Okay? Is clear what I did with the equation?
Yeah, Professor, I got it.
Okay, 1/2 VV squared. So VV squared will be 2 times 40 by J. And I will obtain exactly the same result. 2 times 80G. The square root of 80 by 19.8 is, let's say 800, is the velocity at the point B. If I do the same thing with the initial condition at the point A, not to be like this, to be 30 meters, I will use exactly the same equation and I will obtain again the same result. Okay? Are you feeling comfortable without doing the second part of the example if I do this and I apply this equation? or you want me to apply? In the second,
I think I got it, Professor. I'm just kind of confused on, I guess, how you find the equation for the potential energy and how you derive that, like how it's mgy.
okay. So what you have to understand is that once that you have proved that the work is the variation of the kinetic energy, and once that you know that the work is minus the variation of the potential energy, because this is equal to this, it means that the variation of A sub k plus A sub p is equal 0. You see? It means that A sub k plus A sub p is constant. It means that A sub k plus A sub p at the point A, because it's constant, should be equal to A sub k plus A sub p at the point B. And this is the conservation of mechanical energy. Okay? Catch it? I can go ahead?
Yeah.
Okay, so let's go to do another problem, apply conservation of energy. Let's go to, I have, how you say, a coaster, what you say? Roller?
A roller coaster.
A roller coaster, okay. So let me put a roller coaster. So the roller coaster do like this, do like this, do like this, do like this, okay, and do like this. And let's say that this is yi, this is the floor. You can measure from you can measure from here if you want. It will not make any differences if you want to measure from here. So this is the point A, this is the point B, and this is the point C. And I leave someone with velocity 0 at this point. And the height of yi is, let's say, 50 meters. And the radius of this circle, let's say, is 10 meters. So I want to find what is the velocity at the point B and what is the velocity at the point C, apply my conservation of energy. Do I have to tell you the mass of the object? Do I have to tell you the mass of the object? Yes or no?
Say that again, Professor.
Do I have to tell you what is the mass of the object?
No, you don't.
No,
Because you
have seen that the mass will go out in the equation. But I have to tell you that here there is a force. This is a weight. The weight is pulling down the object. And when the object is here, the weight is down, mg. And when the object is here, the weight is down, mg. So I want to find, there is one thing. The weight is here, okay? In this position, the weight is here. Is the only force that is acting on the body, this force?
No, you have the normal force and
Right, the normal force.
friction.
So this is the normal force. And let's say there is no friction. When I calculate the work equal the variation of the kinetic energy, this work that I calculate is the work done by what force? The normal force or the weight?
I actually don't know, Professor.
Well, it's calculated by the resultant, by the two forces. This work is the work done by the normal plus the work done by the weight.
So it's taking them both into consideration then.
Right. Why? Because when I deduce the equation, I use Newton's law. and I use that the sum of all the forces is the mass by the acceleration. To obtain this result, I have implicitly used Newton's law, and Newton's law says the sum of all the forces equal mass by acceleration. So the sum is here, is the work of the normal and the work of the weight. But how much is the work of the normal? The normal is perpendicular to the displacement. This is the beauty of this. The normal is always perpendicular to the displacement. So what is the work of a force that is perpendicular to the displacement?
It's always zero.
It's always zero. So I don't have to take care of this work. So what I have done is like this. The work done by the weight is the variation of the kinetic energy. A kinetic energy in the final point minus any kinetic energy in the initial point. But I said that also the work done by this weight, the work done by this weight is mg is E sub p of y. A initial minus E sub p of yb. And I have said that the potential energy associated with the weight, with the force minus mgj, the potential energy is mg by the height minus mg by the height. So, in doing that, in putting this equal to this, I obtain the principle of conservation of energy. If you put the A at one side and what is the V, the final another side, you will have this following equation. E sub k of B minus E sub k of A, this work done by the weight is equal to E sub p of ya minus E sub p of yb. So if I put what is y initial together with y with b final, I will obtain E sub k of b plus E sub p of b equal E sub k of a plus E sub p of ya. Or in other terms, I will obtain the equation mbv squared plus E sub p of b mgyb equal 1/2 mva squared plus mgya. And this is the equation that I'm applying all the time. So, once that you are clear, I want you to do this problem. I have how you say, a trolley, what's the name, sorry, what?
A roller coaster.
Roller coaster. So this is my initial position. Remember that the normal will not do any force. So if the normal don't do any force, it doesn't have to be calculated here on the work equal to the variation of energy, kinetic energy, because this is the work by all the forces, not by the weight only. But in this case, the normal force is perpendicular to the surface and it will not do any work because the displacement and the normal force are perpendicular. So I'm lucky. Only I have to take care of this term. So I want you to do this problem.
Professor, are there a lot of cases where the normal force isn't perpendicular to the axis where it moves?
It's a good question. The normal force is always perpendicular to the surface. So if the body have to move on the surface, the normal will be always perpendicular and will never make a change in the kinetic energy, because always will be perpendicular and always the force is perpendicular to the displacement if it's a normal force. So a normal force is a force that his work is zero. No way that the normal force will do a positive or negative work. Why?
Okay, that makes sense.
Suppose that you are here and this is the body. The displacement is going in this direction and the normal is going in this direction. What is the work in this moment of the normal force? The work of the normal force is zero because n scalar delta s is zero because n is perpendicular to delta s because the cosine of 90 is zero. Okay? So if you are here, the displacement has changed, but the normal also has changed and is always perpendicular. Okay? In some way, what we are saying is that the normal force is unable to change the velocity of the object. The normal force cannot change the velocity. Why? Because the normal force is perpendicular to the displacement and the velocity is parallel to the displacement. This is the point. This is the crucial point. So if the normal force is perpendicular to the displacement, it's meaning that the normal force is perpendicular to the vector velocity. And if the normal force is perpendicular to the vector velocity, cannot change the magnitude of v. If v goes like this, if v goes like this and the normal is perpendicular, instantaneously you cannot change the magnitude of v. You can change the direction of v, but not the magnitude, instantaneously. This is something that I have been doing in the videos many times to explain you why. It's something very subtle. It's very subtle. How can be that a force that is perpendicular cannot change the velocity? This is the velocity, and this is the normal force. But I will make the normal by delta t, and by delta t, the force by delta t is the change in velocity. This is the force, because the force is mass by change in velocity per unit of time. So the force, divided by n by delta t. So the force in this case is the normal. The normal is the mass by the acceleration, the change in velocity per unit of time. But this normal, n by delta t, will be something like n by delta v. So delta v will be n by delta t divided by m. So this force that is perpendicular cannot change the magnitude of the velocity. To change the magnitude of the velocity, the force has to be in this direction. Because this will make an increase in the velocities if the force is going in the same direction as the velocity. But if the force, like the normal, is always perpendicular to the vector velocity, cannot change the magnitude of the velocity, but it will change always the direction of the velocity. You see, if you goes to repeat again the name, to a roller what? Well, the velocity is going like this, the normal is going like this. So this normal is changing the vector velocity. Now the velocity is going like this and the normal is going like this. Now the normal is going like this. This normal is what it makes the velocity to change in direction, but cannot change the magnitude of the velocity. Okay? So my problem is like this. This is the problem that I want you to do. I have a roller coaster. This is 10 meters. This is the point B. This is the point, sorry, this is the point C. This is the point B. This is the point A. The velocity v sub A, let's say, and and the height is 50 meters. Okay, this is 10 meters, and this is another 10 meters because it's a circle. Even it doesn't look like a circle, you imagine that it's a circle. So I want to find, in this case, what is V sub B and what is V sub C. How I will find it? I will put a mechanical energy at the point A equal mechanical energy at the point B equal mechanical energy at the point C. And what is mechanical energy? Mechanical energy is kinetic energy plus potential energy at the point A, evaluated at the point A, equals kinetic energy plus potential energy evaluated at B plus kinetic energy plus potential energy evaluated at C. So I am saying that the mechanical energy is the sum of the kinetic energy plus potential energy. And define what is the mechanical energy at the sum of kinetic energy and potential energy. So I want to do this problem. I'm going to give you 5 minutes. Would you like to go to rooms to make it more comfortable? Or no?
I think like this is fine, Professor.
Okay, so I'll give you 5 minutes to solve it. Everyone will solve this problem. And the problem say, what is VB and what is VC? That's the problem. I'm not, well, of course, there is mg here. G is minus 9.8 meters per second squared. Of course, there is acceleration in this direction. There is the weight is making work. There is the work, the weight is mg, the force of the weight is mg, j, minus mgj. This is the basic thing that we have in this problem, that there is a force that is here making work. This is the basic thing. If we don't have this force, nothing is moving the object. If we don't move the object will stay there if there is no force. So the basic thing is that we have this force, the height is this one, 50 meters, and I want to find when the height is 0, and I want to find when the height is 20 meters. So do it. I'll give you 5 minutes to do it, okay? And let me go to the restroom meanwhile. And I'm very sorry that you cannot see me. You cannot imagine how bad I feel to not being able to put this video. If someone can give me an idea what I can do to put this video, I will really appreciate it.
Did you press start video, Professor?
Yes, I did it many times.
Maybe your the camera on the computer itself in the settings is off.
Oh, how can I go to the camera of the computer? I have an
You would have to go to settings
setting.
and then
Yes.
There should be a section where it says hardware or devices. I'm not exactly sure, Professor, where exactly to go, but somewhere in settings it should tell you if your camera is working or not.
Are you using your computer, Professor?
Yes, I'm using my computer.
Are you sure that the screen, like the computer, like the camera on the computer isn't blocked, like with paper or a film?
I don't know, maybe it's blocked and I didn't.
No, like, do you see anything on your computer, like on your camera on your computer?
No, my
Anything covering it in person?
camera is black, completely black. My image doesn't appear.
No, not your image, on the physical camera. Do you see, like, sometimes I have my something blocking my camera so people can't see me in case my camera turns on. Do you have anything like that? Like to block the camera Maybe that's what it is.
It can't be that because it's like the
It's
screen on him is gray, so it's not like it's black or anything.
oh,
It has to be something in your settings, Professor.
but it doesn't. It could be. I don't know.
But it's okay. It's not a big deal. We'll see your face in the next class.
I will reset the computer and maybe the problem is solved. Okay, but I'm sorry that you cannot see me. So I'll give you 5 minutes to solve the problem, okay?
Professor,
Yes,
the message that you sent us regarding 4.12,
yes, I have sent you a few problems that I think that you should know how to do it. It's about Newton's law. If you remember, on Unit 4, I solved many examples, like 8, 9 examples of Newton's law, but I didn't give you any homework because you were very, very late with Unit 3, I remember. So I decided at that time not to give you any homework, but more homework, because I was feeling that you were very, very stressed with so many homework. But now I think it's time to work with Newton's law. You can start doing slowly by slowly. There are 10 problems, I think. You can do one every day and take it with calm, because I'm not going to rush you to submit it until the end of the course. So do not worry. You make whatever you like to do with this problem. Meanwhile, the 15 days is, we have around 15 more days to work, no? So tomorrow I will upload Work and Energy. I will upload my notes. I will upload video explanation of the notes. Everything that we have done in the class, I will upload something similar to explain you what we have done, and I will upload problems for Work and Energy that I will request you to do it before Tuesday or
okay,
Thursday, because I was planning to make a small quiz on Work and Energy soon, no? Maybe next week. Today is Tuesday, or was today?
Today's Thursday, Professor, and you said the quiz was going to be on Tuesday.
Maybe we'll do the quiz. Maybe we'll do the quiz on next Tuesday. Maybe we will decide. Let's go to finish the class. So,
Professor, I have a question about the problem. Where's the position, Y position of B?
YA is 50, YB is 0, respect,
Oh, B 0, okay.
and
And then C is 10.
20, because 10
Oh, I see.
use.
Is the halfway. Okay, got it. Thank you, Professor.
Okay. Go to the restroom just a moment, please.
Hello? Okay.
Hello.
No, sorry, just testing to see if my mic is working. Sorry.
Oh, I'm here.
Hey,
Okay.
Professor.
Hi. Is done the problem?
Yes.
Yeah, I got B, but I think I'm a little stuck on C, but I think I got it.
Okay, let's go to do it. And we review everything. So on the point A, I have to calculate this term, kinetic energy plus potential energy. On the point B, I have to calculate this term, kinetic plus potential energy measured at the point B. And on the point C, I have to calculate the same term. And all these are the same thing. It's the same quantity. What happens is that the kinetic energy increase, the potential energy decrease. So this is the way it's happening. The way it's happening that the energy is conserved in a way that when you increase the kinetic energy, you decrease the potential energy in a way that the sum is always zero. So in our problem, we have kinetic energy at the point A, 1/2 m0 squared. Potential energy at the point A, mg by 50. Kinetic energy at the point B, I don't know. Potential energy at the point B, 0, because YB is 0. Kinetic energy at the point C, I don't know. I don't know the velocity at the point C. And potential energy at the point C, I know, mg by 20. So I will work with my equation. I have this set of equations, this set of equations, and this set of equations. And the sum, the mechanical energy at any point, is constant always. So let's put this right. So sorry, just a moment. So I would write this equation. Kinetic energy plus potential energy at the point A equals kinetic energy plus potential energy at the point B equal kinetic energy plus potential energy at the point C. And what I expect is to find VV and VC from this equation. The kinetic energy at the point A is 0. The potential energy at the point A is mg by 50, is equal. The kinetic energy at the point B is 1/2 mvv squared, plus the potential energy at the point B is mg. The potential energy is always mg by y, but y is 0 at the point B, plus 0, equal. The kinetic energy at the point C is 1/2 mvc squared. The point C is here. You remember the picture, no? This is the point C. So I don't know what is the velocity at the point C, but this is what I want to find. I want to find the velocity at the point C. And the potential energy at the point C is mg by the height. But the height is not 10 meters, it's 20 meters. Okay? This was 20. So, very easy. Very easy. With two equations, I find this should be. with these two equations, I will find B sub C. Or maybe with the last one and the first one, I will find B sub C. I will have mg50 equal 1/2 mb sub c squared plus mg20. The ends will go out, and what I have is 50 times g minus 20 times g equal 1/2 b sub c squared. So what I have is 30 times g by 2 equal b sub c squared. This implies that b sub c is a square root of 60 by 10. B sub c is a square root of 600. Everything in meter by second. Is that difficult?
No.
No, is everybody, can I, there is here on Zoom there is an application that say, vote, no? Something like this, no? I think that I have seen, let me see. Let me see. No. Just a moment, please. Okay, I'm here. Okay, this computer is not working correctly, I think. Something is failing. Oh, here, let me see. Let me see just a moment. Oh, there is a chat here that people, because it's perpendicular than cell. Okay. Okay. So I want to introduce you to the next chapter. The next chapter is about rotations. What happens with a body rotates? And I want to introduce you step by step. So let's go to define. Imagine that you have an object. Like, for example, a disk. Let's go to take a disk. This is your disk, okay? This is the disk. In my times, we listen to music with a plastic disc, like this one. And the plastic rotates, we put a needle here, and the needle produces the sound of the music, and you can listen to the disc, okay?
Professor, not to interrupt, but could you please scroll up a little bit so that I can take a screenshot of the work that you just did?
Why not? Like this?
Yes, just that.
Okay.
Thank you.
So,
Okay, that's it. Thank you.
so this is the disc. When the disc starts to rotate, what happens? This point is moving with certain velocity. You rotate and every point will move with certain velocity. Is the magnitude of this velocity bigger than the magnitude of this velocity? What do you think? That this is rotating. You think that the point A and the point B, is the point B going faster than the point A? Or is the point A going faster than the point B? What do you think? So this is the disk. The disk is rotating.
Well, maybe B because it has more time to accelerate.
Well, if you say that B is going faster, after some while, A will be here and B will be here. Right?
Yeah.
I think if you say that A is going faster, after some times, V will be here and A will be here. And the distance will be smaller than initially. What do you think that it happened? The first one or the second situation? Is A going faster than B or is B going faster than A? In other words, if you put a mark here and you put a mark here and you leave these to rotate, it will maintain the distance, the point A, the marks will dilatate or will maintain the distance?
I honestly don't know. I'm guessing maintain. I don't know.
Of course, it will maintain the distance. There is no distortion in the disc. The disc is rotating like a solid that maintains the distance meanwhile it's moving. So, when I have something moving, let's say a view, let me do a nice circle, sorry. Let me do a nice. So the velocity is the same for this point. When he's rotating, at the instant t, the velocity of this point and the velocity of this point is the same exactly. Maybe the disk will start to rotate faster. So this velocity will be this, bigger, but also this velocity will be bigger instantaneously because it's a solid. It's a rigid solid. Okay? So the velocity is like this. Second question. If this is rotating, the velocity of this point will be the same than this one or will be smaller?
The same.
Well, no, it will be quite smaller. So why? Why is this thing happen? So
Because of the rotational velocity?
because what, Maria?
Because it's the rotational velocity, so it's against like drag or something?
See, yes, something like this. But let's go to prove it that the velocity is lower and the velocity depends on the radius. This
Oh, sorry. I didn't see that you had selected a smaller point closer to the radius. It's because it's closer to the radius, right? The radius is smaller?
Right. So when you have a body moving in a circle like this one, or like this one, this is the radius R1, let's say, and this is the radius R2. So this is the distance delta S1, and this is the delta S2. Can you tell me, and this is the angle delta theta. Should I put delta theta 1 or delta theta 2?
Can you put delta theta 2?
No. Should I put theta 1 or delta theta 2? Maria say put delta theta 1. Diego say, for example, put delta theta 2. What delta?
I say 2.
Which one?
Yeah, what you said. I'll say delta theta 2.
Delta theta 1, the angle when you go from A to B is the same angle when you go to A prime to B prime. So I should not put delta theta 1 or delta theta 2. I should put just delta theta because it's the same angle that is going to vary. It's going to sweep the same angles from A prime to B prime that from A to B. So, catch it or not? Convinced or not?
Yes.
Of
Yeah.
course, the same angle. Delta theta 1 is equal delta theta 2 is the angle delta theta. So what is the expression that connects delta S1 with the radius R1. Let's go to put R1, capital R. What is the connection? Delta S1 is equal to unit 1. The length of the arc in a circle, the length of the arc.
Oh, is the radius times the angle.
All right. What is delta S2?
R2 times the angle, because the angle is the same.
Angle delta theta. What it means delta S1 divided by delta T. What it means the distance travel from here, from A to B, delta S1 is the distance travel from delta to E, from A to B divided by delta T. What it means this? It means V1, the velocity here, the velocity that is here, okay? What it means delta S2 divided by delta T. Oh, it means V2 is the velocity between these 2 points. Is the average velocity, the displacement divided by the time that they like to displace is the velocity V2. What is the relation here? The relation is that delta S1 divided by delta T is equal to R1 by delta theta divided by delta T. And the second relation that I have is that delta S2 divided by delta T is R2 by delta theta divided by delta T. I have divided equation 1 by delta T. I have divided equation 2 by delta T. And I have obtained that V1, equation 1, V1 is R1 by delta theta divided by delta T. I will call this omega 1. And the second equation will read that V2 is equal R2 by omega 2. Can you tell me what is the mistake that I have done? The conceptual mistake that I have done? The conceptual mistake that I have done is the same one that you did at the beginning. Omega is delta theta by delta T. So this is omega. So this is omega also. I cannot put omega 1, omega 2. So I have to put omega 1 equal omega 2 equal omega. So I have to put omega, because omega is the angular velocity, omega. Omega means how many radians you move in how long. Omega is the relation between the angle that you move divided by the time that it takes to move. But the angle that you move, if you see this picture, the angle that you move from T1 to T2 is the same angle. So the omega is the same one for point A and A prime. Catch it?
Yeah, that makes sense. Yeah.
Catch it that omega is the same one? So the relation that I have is that V1 is omega by R1. The omega is the same one. V2 is omega by R2. The omega is the same one. What is different is the radius. So the velocity V1 is bigger than V2 if R1 is bigger than R2. Is clear? So the exterior velocity, how I call R1, R2, R1 is bigger, yes. So the exterior velocity is moving at a higher speed because it has to go around one circle, one revolution, but it has to go the exterior circle this point is faster than this point. Why? Because when he goes around a circle and go one revolution, this point have to make all this distance in a time t that is the same point that it will delay this point to make all this distance. But this distance will be smaller than all this distance. So the relation between the length L1 or L2 and L1, L2 divided by the time T2 will be smaller than L1 divided by the time, let's go to delta T. So the distance, the circle, the length of the circle of L2 will be 2 pi R2 divided by delta T will be the velocity in the circle 2. While I say that 2 pi R1 is the length when you move in the circle, in the exterior circle, and you delay the same time to go one revolution. This point delay the same times to go one revolution. When this point is here, this point is here. When this point is here, this point is here. When this point is here, the point is here. And when it arrive here, when it arrive to the initial point, this point is here. So this one have to go only a few meters in the same times. A few meters is slower than this one that have to go around. He has to run too much. He has to go fast. This is faster. And the relation is that V1 or VA, let me check VA. If I put this the point A and the point B, the relation is that VA is omega by RA, and the velocity VV is omega, the same omega, because they display the same angle per unit of time. BB, sorry, just a moment. I don't know why it's not right in this. Just a moment. Oh. You see the screen? Sorry.
Yeah, I think it's because you were on the eraser before.
No, it was close. It was, I don't know what happened. I think that I lose all the work. Wow. I lose all the work. Okay. So what I said, that the point A and the point B, what I say that when this is rotating, the point B has a velocity and the point A has another velocity that is smaller. And what I say that VA is omega by RA and VV is omega by RB. And omega is equal to omega. These omega are the same because are the angle divided by the time. And the angle they move are the same angle in the same time. So this omega is the same one for the point A and the point B. So once that this is clear for rotation, I want to introduce one quantity in rotation. When you work in Newton's law, we work with momentum. Momentum is the mass by the velocity. So you have the object, you have the velocity v, and you have the mass m, and you construct a new vector that we call the momentum, that if the mass is 3, if the mass is 3 kilograms, well, the momentum will be 3 times v. So the momentum is the same vector that this vector v, but 3 times in this case. if the object has 10 kilograms, well, the momentum will be 10 times this vector velocity. So in Newton's law, we work with this momentum and we said that the force is the change in momentum per unit of time. And I have proved you in the class that this is the same thing that to write m by a. But to see the equation in this form is more powerful because you see where the momentum is changing. So this is what we see. Now in rotation we have a new vector, and the new vector is called the angular momentum. L is a vector, and L is defined like this. This is the object. The object is at the position R. Imagine a disk. Imagine this is a point of the disk that have mass m. So the point is moving with certain velocity v. So we say that here there is a momentum, angular momentum, not linear momentum. P is linear momentum. Yeah, just a moment, please. Just a moment. Just a moment, please. So L is defined like this. The angular momentum, so P is linear momentum, L is angular momentum. And why angular momentum? Because P is linear because it's related to displacement. The body that we use in Newton's law is considered like a point, cannot rotate. A point cannot rotate. Now we are considering something like a disk that can rotate. So this is the equivalent. We are going to construct the same equation as Newton's law, but in completely another terms. Instead of putting F equal the change in momentum divided by the time delta t, we are going to construct the Newton's law for things that can rotate. And we will see what will be the Newton's law, but the Newton's law will be an equation that will say like this. The torque is the change in the angular momentum per unit of time. So let's go to define what is the angular momentum, what is the change in the angular momentum, and what is the torque. So let's go to start from the beginning. So, one, definition of angular momentum, L. We define L as R cross MB. The cross product of two vectors. What vector? The position and the momentum. And we construct this angular momentum. What is the magnitude of L? The magnitude of L is the magnitude of R by the magnitude of MB by the sine of the angle that makes R with B. So maybe R is like this is the point, and maybe B is like this, so the angle that makes R with B in this case will be 90 degrees. But if the case is like this is R, and V is like this, the angle that will make R with B will be less than 90 degrees. So the angular momentum is a vector that has the magnitude like this magnitude. What it means like this, that if R is like this and V is like this, what will be the sine of the angle between R and B? Will be the sine of 0, but the sine of 0 is 0. So the angular momentum in this position is 0. The angular momentum in this position is maximum because sine of 90 is 1. And the angular momentum, the magnitude of the angular momentum, is the magnitude of r by the magnitude of mb by the sine of this angle, 30 degrees. Okay, I will put 30 degrees. This is the definition of the angular momentum. And why is that good vectors? Well, give me a few minutes and I will tell you why this vector. So let's go to do one example.
Professor, could you scroll up a little bit?
Yes. Like this.
That's fine, yeah. Thank you.
Okay. So example. Let's imagine. Yeah, yes. Liliana. Lili, mi vida. Es que estoy en clase, disculpa. So let's imagine we have a mass M equal 1 kilogram moving in a circular movement with velocity v equal so I need to write the velocity. So the velocity is always equal, let's say, 5 meters per second in the direction of u sub t, tangent to the circle, always tangent to the circle. So u sub t and r are two vectors that are how they are. Always. Are what? Parallel? Is u sub t and r parallel or perpendicular?
Perpendicular.
Perpendicular always. So the velocity is always perpendicular to the position. So how we will find the angular momentum? The angular momentum, the magnitude of the angular momentum will be m by the magnitude of v by the magnitude of r. So it's moving with a circular movement in a radius of r equal 10 meters. So by the sine of alpha. So this is the magnitude of the angular momentum. So the magnitude of the angular momentum will be the mass, 1 kilogram, the velocity is 5, the radius 10, and the sine of the angle will be 90. Sine of 90 is 1. 10 by 5 is 50. 50 what? The unit of angular momentum have no special units. It's like the momentum, the unit of the linear momentum P is mv is kilogram per meter per second. What are the unit of L? The unit of L is kilogram per meter per second square. Okay? So this is kilogram per meter square divided by second. This is the unit of angular momentum. So I have a vector L that have the magnitude 50. And now I wonder, okay, but a vector have a direction. What is the direction of this vector? You have to tell me the direction. Because if you don't tell me the direction, you don't tell me what is the vector. So the vector is defined here. It defined, oh, right here. It's defined, it was erased in the last time. I said that the vector L is the vector R cross MB, or R cross B. So I make the cross product of R with B, and I will find the direction of L. So I found that the magnitude of L is 50, so I need to make R by V. So how I will do? Let's say that this is the plane XY, and let's say that the object is rotating in the plane XY. So R will go like this, V will go like this, always perpendicular. So R by B will be going up. Okay. Okay, always go up. Catch it or not?
Yeah.
Yes, that's why at the beginning of the course I have met you to make problems about cross product and scalar product, because we were going to use it. So I'm going to give you a few minutes to rest, and meanwhile I'm going to ask you something. I receive, if you can use this time please to do the following thing, I will appreciate. Let me explain you. You know what is perception? Do you know what is perception?
Perception, like how we perceive things?
Yeah, how you perceive things.
Sure.
Do you perceive that the stock market is going to be up or down? Huh? What do you perceive?
Well, I perceive that there's going to be stocks right now that are going to at a low price, but soon they're going to be shooting up.
Are you not in shock when you see the situation that I see many companies that is going to be in bankruptcy soon?
Yes, of course.
Not working, and the unemployment is too high, and the stock market is going higher and higher. Why people perceive that this is not going to happen? People is perceiving in the stock market that what is going to happen is that many stock market will go up. But perception is something very, very subtle. And you can realize that human perception is very strange. It has happened to you sometime, for example, that you buy a new car and suddenly you are driving your car and the street is full of your car. Everybody is driving a car like you. Have has happened like this to you? Sometime?
Yeah, because
What happened is that your perception, your perception changed, and it changed in a way that now the filter that you had before, the filter that you have in your brain before you bought your car, now the filter doesn't exist. And now suddenly you can see many cars like yours. So it means that the perception changes all the time. Human perception is something, when you meet someone, for example, you have a perception, in 30 seconds, you know, you think that you know, you don't know. You think that you know, this guy, I like this guy. I think he's an honest guy. I think that this guy is going to be my friend. Or maybe your perception is contrary and you say, this guy, I will never go with him to the movie, maybe. But your perception is something that is the mix of many things, and your perception can be wrong. So when you make a decision, you have to think what really are your perception, and to take the filters that makes you not to perceive the whole thing, make the filters to go out. sometimes what makes you to take out the filters is to buy a new car. But you cannot stay buying things that to perceive things, you know? What I mean is that what I was telling you is that I received an email from FIU that say, please tell to the student to go to the spot, to go to my FIU.edu and fill in the student perception of teaching surveys. So I want you to fill in, I want to give you 5 minutes to fill in this student perception of teaching survey. Is it going, please do it now. Is going to, you go to myfiu.edu and you will find a word SPOTS. And you fill in, I think it's very, very quick to fill in. And what I want to ask you is, sometimes I see perceptions of a student that really hurt me. For example, it will hurt me a lot if you say, this is a drunk professor that makes video when he's drunk. It can happen. It can happen that people it's saying like this and perceiving things like this. So check your perception and please make the spots now in a way that you are honest what you say, you are sure what you are doing, and please don't put silly things. If you have in your mind something silly, please check with your friends and say, I have in my mind this, it can be possible or cannot. If it can possible, if it's possible, well, you write whatever you think that is the perception. But make the student perception of teaching survey. Can you do it now? Can you do it now?
Yeah, we can do it now, Professor. I just don't know how long it's gonna take. If it'll take, probably might take the rest of class time. Because class ends in 10 minutes.
Okay, please do it now if you don't mind. I will appreciate if you do it now. Or if you want, we can do it on Thursday, on Tuesday. I don't mind, no.
I don't think they take that long.
Professor, but we don't have to be together to do them. Like we can just do them.
FIU,
Yeah, I know, but
myfiu.com for the survey.
to take during the class to tell you to do it during the class. I don't know why they told me. I can send you the email that I received. Let me send you the email that I received so you can okay, let me send you the email that I received. Okay. Okay, sent. There is the, okay. Okay, so we end the class here. You want to end the class here? It's 3:30. We'll end the class here and I will see you on Tuesday, okay?
Okay, sounds good, Professor. Thank you so much for today.
Please.
Have a good weekend.
Have a good weekend, so I beg you, please, when you feel in the perception, try not to say things that are not perceive things. Try to take out your filters out and perceive things as it is the real thing. Do not make distortions on the perception, please. I beg you. It really hurt me when someone says something that I consider that is a distortion. It's a complete distortion of the reality, no? And it happened. I know that it can happen. You can distortion the reality and believe that something is happening when it's not happening what you think. So that's why I told you that perception is something that is very, very subjective. It's not objective thing. So
Got you back.
have a good weekend. I'll see you on Tuesday. Please please check your Canvas to see what I'm going to upload for work and energy. Please work as fast as possible. Do the homework that I'm going to request you to do it, and I will see you on Tuesday.
Thank you, Professor.
Thank you,
Okay.
Professor. Have a good weekend.
Thank you.
Thank you. Bye, Professor.
Thank you, Professor.
More questions.
Professor,
More,
Professor,
yes.
I was going to ask you something. I mean, I'm sorry because I know we talked about it last class about the grades. I received the picture that you sent me, but like my third quiz, like I sent it to you, but you say you was going to grade it like manually, but I don't think you graded yet. But it still appear on the picture that
Don't
you know.
worry. I will do it on Tuesday. Benji, on Tuesday we'll review
Yes.
and we'll see if I have done or I have not done. I will do it in front of you. Okay.
Okay. Thank you very much.
Okay, Benji. Have a good weekend, everybody. Take care. Be careful.
Okay. Yeah.
The coronavirus and enjoy life.
Professor, we'll still be able to meet with you next Tuesday or the following this Tuesday coming up for to like talk about our grades and stuff
You mean to review the grades? You want?
on Tuesday.
Yeah, on Tuesday. Yes, please. On Tuesday we'll review it again. All the grades. Whatever you need, we will review it. Okay.
Okay, thank you.
Okay. Have a good weekend. Thank you very much.
You too, Professor.
Thank you. Okay, can I close the meeting? Yes?